For this question, given that exy equals to sin x, so that d2y dx squared plus 2dy dx plus 2y equals to 0. So look at our function here, ex times y. So our y is multiplied with the x function. So you have two options here. One is we move the ex to the right hand side to do it as explicit function. So second option will be we remain the equation like this, but when we want to differentiate, we will be involving implicit differentiation. So I'm taking the second option. So I'm not going to move it to the right hand side doing quotient rule with the explicit differentiation. So I will maintain the equation and we differentiate straight away. So for the function at the left hand side, we have ex multiplied with y, two functions multiplied together. To differentiate this, we need product rule. Copy the front one, differentiate the back, then copy the back function y, differentiate the front. So differentiate y, we get dy dx. Differentiate ex, we get ex. Then we done our product rule here. Then we move on to the term at the right hand side. Differentiate sine, we get cos. So we need to differentiate again to get second derivative. To differentiate again, so observe our term. We have ex multiplied with dy dx. Product rule, since we have two functions together. And then for this next term, y times ex also multiply two functions together. So also product rule. We differentiate the first term first. Product rule for this term. Salin yang depan, differentiate yang belakang. Salin yang belakang, differentiate yang depan. So copy the front function, differentiate dy dx, become d2y dx squared. Then copy the dy dx, differentiate ex, we remain having ex. Continue. For the second term here, so copy the y, differentiate ex, plus copy ex, differentiate y. Differentiate ex, you will have ex. Differentiate y, it is implicitly become dy dx. Then we move on to the right hand side. Differentiate cos, which is negative, sin x. Differentiate angle, we get 1. Then we observe our equation we need to show here. We will going to modify until to get this equation come out. So first of all, you can see the function here is without x, and the right hand side is without term here. First of all, we can move all the term to the left hand side. And then, so we can see the coefficient here is without ex, we are going to divide this ex. So we get d2y dx squared. And then we find for the similar term, you can see ex dy dx, ex dy dx. So actually they are similar. When you take out your ex, when we divide our ex, we have dy dx plus dy dx. So these two terms give us 2 dy dx. And we divide this ex, we get y. Then for this sin x, we need to divide by ex equals to 0. So we are getting closer to the equation we need to show, just we don't have sin x over dx. So you can observe here, we need to multiply this sin x over ex in terms of y. So we look back our questions here. Original equation here, where sin x over ex, it is equals to y. Move your ex to the right hand side, you will get sin x over ex. So this term can be substitute it as y. Therefore, y plus y will equals to 2y.